Hello, and welcome to Astronomy 100. In this segment, we're going to continue our discussion of stellar properties. And in particular, we're going to focus our attention on one property, and that's the idea of stellar mass. Now, when it comes to understanding the mass of a star, it turns out that that's the single most important thing you could ever know about a star. Now, let's remind ourselves what the concept of mass means. If you remember from a previous show, we talked about how the mass of a star is the quantity of material that the star is made out of. And don't confuse the concept of mass with weight. Remember that weight is how two objects gravitationally interact with each other, because of their mass, of course. But mass is fundamentally the amount of material that something is made out of. So the Earth is made out of a certain amount of mass, the Sun is made out of a certain amount of mass, or the Earth is composed of a certain number of atoms, and the Sun is made of a certain number of atoms as well. Now, why is mass such a critical thing to know? Well, it turns out that the mass of a star determines almost every other property of the star. The reason for this is because of gravity. Gravity depends on the mass of the object. And what we're going to find out eventually is that the gravitational pull of a star will determine many things about the star. The gravity of a star determines how that star produces its energy. The gravity of the star will determine how that star goes through its fuel. The gravity of a star will determine how that star ends its existence. And of course, it'll determine what the star becomes once it's finished being a normal star. So because gravity is such an important concept, the mass of the star, of course, is going to be an important item as well. So the problem, though, is how do we determine the mass of a star? Mass is not something that you can determine by looking at a star. An example is, there are objects that are a certain size because of their mass. An example is a rock that is a big rock is going to be more massive than a rock that is a small rock. But when it comes to stars, they're not made out of solids, they're made out of gases. And gases can be compressed or gases can be sort of expanded. And so the density of the gas can change, and that of course will change the size of the star without actually changing the quantity of the gas. So we can't simply say that a star that is a big star is more massive than a star that is a small star. So we need some other method to be able to determine the mass of a star. The way that we do this is, in reality, by letting nature do it for us. And that's where the concept of binary star systems come in. Let's have a look. In nature, there are situations where stars are not alone in our universe. They actually exist as a pair or a triplet or quadruplet. And fundamentally, we refer to these as multiple star systems. Traditionally, they've been called binary stars. Binary implies two, but in reality, it can be more than two. And so when these two stars are together, it is actually two or more stars that are orbiting around each other. And by the nature at which the two stars move is determined by gravity. And of course, gravity depends on mass. In this picture that you see right here, this is a photograph of two stars that are together in space. One star is very golden in its color, the other one is very blue. But these two stars are companions in space. They're going through the galaxy together. And over here to the right is an artist's rendering of what it might look like if you were on a planet that was going around a binary star system. You'll notice that in this view of the sunset, you have two stars in the sky instead of one. So it would be something very normal if you were to live on a planet such as this one, seeing two stars in the sky. So in a multiple star system or a binary star system, it's actually two or more stars that are orbiting around each other. Let's look at some of the details. We've learned a few things about binary stars over the years. And in particular, as I said, by definition, it must be two or more stars that are together. But what they're doing is they're orbiting around what is called a common center of mass. And this illustration, this animation over here on the right is demonstrating that. You'll notice that the two stars are moving, and you'll see that there's this little plus sign or this cross that seems to be the point that they're moving around. notice that they're both moving. It's not one star moving around another star. It's actually two stars that are moving around this point. Notice they keep that point constantly opposite of each other. In other words, they are opposite that point and they're opposite of each other. They keep that point in the middle between the two of them. So this is called the center of mass. Sometimes this is called the center of gravity, and that is actually the balancing point between these two stars. And we'll talk more about that in a little bit. Now, we've learned some things about binary stars over the years. The first existence of binary stars were suggested by Isaac Newton. Isaac Newton said it could be that gravity could make it so that you can have two stars orbiting together, very much like the moon and the earth orbit together, or that the earth and the sun orbit together. So the suggestion of a binary star system goes all the way back to the time of Isaac Newton. But it was in the late 1700s when we started to actually discover their existence that we found that you truly do have two or more stars together as groups in our universe, that it is not just a suggestion, that it's actually a reality. So in the centuries following that, we've studied them quite a bit and we've learned a great deal about them. And so let's share a few of the details that go with them. The stars themselves are together as a pair, but one of the questions that, of course, is sort of implied is how do they become that way? And so historically, there were several suggestions as to how you could possibly get a binary system. The first suggestion is called the capture theory. And the idea is that you could have a star moving through the galaxy that happens to encounter another star moving through the galaxy. And the gravitational pull of these two stars will cause the two stars to come together and then end up being a binary system, or having one star be the companion of the other star. The problem is that in reality, the odds of having two stars come close enough together to encounter each other is actually very, very slim. It's not impossible, it's just highly improbable to get two stars together. And the main reason is that the stars in our galaxy are actually very, very far apart. There's a way that you can visualize just how far apart stars are in their normal travels around the galaxy. The way you can think of it is, if we were to take the sun and shrink it down to the size of a grapefruit, so let's say we shrink the sun down to something about this big, our nearest neighboring star system is Alpha Centauri. And Alpha Centauri is a little more than 4 light years away from us. Now, Alpha Centauri is technically a triple system, but if we take the main component of that, it would be another star about the size of a grapefruit. And if we put the sun on the desk as the size of a grapefruit, the nearest neighboring star, Alpha Centauri, would be placed on a desk in Washington, D.C., if we're located here in San Diego. So can you imagine the gap between two grapefruits, the width of the United States? That is the relative size distance between typical stars in our galaxy. They're enormously far apart. So the odds of having two stars encounter each other just isn't really going to work. Another suggestion was that it could be that you had one star that was spinning very, very rapidly. And the spinning of a star means the material of that star has forces outward. And as something spins very, very rapidly, the forces outward could tear part of it off. Because a star is made out of gas, a star spinning very, very rapidly could throw off some of its own material that could then later become another star. So think of it as one star becomes two. This is what's called the fission theory. So lots of ideas as to how you could possibly get a binary star system to occur. The problem with the fission theory is that you have to have a star spin very, very fast to get those forces to occur. And we would find lots of stars in our galaxy that are still spinning very fast, and we just don't seem to find that. So the one concept that has withstood the test of time that seems to be correct is what's called the co-creation theory, which means that in a binary star system, it is two stars together because they formed that way. Instead of one star forming, you had a cloud of gas that becomes the star, but it becomes two stars instead of one. And what we will find later on in the semester, we'll find how stars form. We'll talk about how that works, and you'll see that that's just the likely scenario. So when it comes to binary star systems, you should think of them as siblings. They are together as a pair. They form that way. They are the same age. Now, the last part's an important part as well. What we now know is that binary star systems make up more than half of all stars in our galaxy. So the odds that you have a binary star system in our galaxy are greater than 50-50, meaning it is the most common type of star system that you'll find in our galaxy. Stars don't exist as single solitary stars as much as they exist as pairs or triplets or quadruplets. So binary star systems are actually the norm. And that makes the sun actually in the minority. The sun being a single star is actually rather rare. So let's talk about some of the different types of ways that we can learn things and how, of course, binary star systems can tell us the mass of the star. The first thing that you should know is that there's ways of looking at binary star systems. This first category here we're going to call visual binary systems. And in this animation over here on the right is an example of that. What you're looking at is actually multiple photographs of a star system. And so these pictures were taken over years. So think of it as picture after picture after picture over a span of a couple of years. And what you can clearly see when you run all those pictures together is that you have two stars that are clearly together as a system, as a binary system. And you can see that the one star is moving in an orbit around the other star. And the reason why this becomes significant, of course, is that this is now going to show us all of the information that we need to know. So a visual binary star system is literally just that. It is a system of stars that you can visibly see both of the stars, both of the companions. So you can resolve the fact that it is actually two stars together as you look at it through a telescope. And so a visual binary star system is actually a very, very good thing to find, because what it does is it will actually show us everything we need to know. For instance, the way in which these two stars are orbiting around each other is determined by gravity. Gravity is what makes the orbital mechanics what it is. And if you remember in a previous segment, we talked all about orbital mechanics. So because gravity is determining how these stars are interacting with each other and how the orbit is occurring, then if we study how gravity is creating the orbit that we see, we can figure out the masses of the stars, because gravity depends on mass. So what you'll notice is that as these stars are doing what they're doing, over a period of time, we can actually plot the orbit very precisely. And you can see that over a span in this example of many years, you can actually see the movement of the one star around the other star. And it is the orbital mechanics of this movement that is because of the masses of the stars themselves. So by witnessing the movement of a star in a binary star system, because it's due to gravity, we can figure out the masses of the actual stars. Now, what is the physics of how the orbital mechanics will translate into telling us their masses? That's something that we can work on, and I'll show you the details of how their movement can be translated into understanding their masses. But we're just about out of time, so we're going to save that topic for the next time. I hope you'll join me.